Hey, what's up, everybody? Sorry I can't be there. As I said before, I am at a meeting. So I will be there absolutely on Friday, unless there is a cold day. In that case, I will be there on Monday, and I'll see you guys then. Um, so let's go ahead and take a look at the notes. So we're at notes 7C, power to a power and fraction to a power. So here we go. So remember, if you guys remember what we learned a few days ago, right? Whenever we had a base to a power multiplied by a base, a similar base, or a congruent base to a power, we add the exponents, correct? Right? In this case, when we have a base um to a power to a power, right? So in this case, we have an exponent n to the power of n, another exponent n. What we do is, instead of adding like before, where we would multiply, right? When multiplication is just add addition over and over again, in this case, we do m times n, so we actually end up multiplying. So, and you'll have that quote right there, right? Keep the bases the same and multiply the exponent. So in this case right here, we have 2 to the power of 3 to the power of 5. So this is just 3 times 5, which gives us 15. Now, why does that work? Well, let's expand to see exactly what that means. If you guys remember before, when I taught you guys about exponents, if we had something like 4 to the power of 3, well, that's just 4 times 4 times 4, correct? So if we have x to the power of 4 to the power of 3, then this is going to be x to the power of 4, or x to the fourth, times x to the fourth times x to the fourth, right? Now, we learned this 2 days ago, that x to the power, in this case 4, right? X to the fourth times x to the fourth times x to the fourth, we keep the basis, so in this case x, and we add all the numbers, so all the exponents. So 4 plus 4 plus 4, well, that's just 12, right? Or remember, 4 plus 4 plus 4 is just 4 times 3, which ends up giving us a final answer of x 12, x to the 12th power. How would that look like here? Well, I have m to the power of 2, right? And again, we're going to go ahead and do that 5 times m squared times m squared times m squared. Do that 5 times. Well, that's just 2 plus 2 plus 2 plus 2 plus 2. Remember that multiplication is just addition over and over again, so that's 2 times 5, which ends up giving me a final answer of m to the 10th. Now, what happens when we have two variables? Well, when we have two variables, the exact same thing ends up pretty much happening, where we have x to the fourth times y to the fifth times, we want to do that 2 times. So that's once, x to the fourth times y to the fifth. And now, remember, these are all being multiplied. So I can combine my exponents here, my x fourths. So I have x to the power of 8. And we can combine our y fifths. So y uh, to the power of 5 times y to the power of 5 is y to the power of 10, right? That's just x 4 times 2, y 5 times 2. Excellent. So the way I'm going to keep doing things is, right, I'm just going to be multiplying them from now on. But please refer to this area if this page here, this section here, if you guys are still a little confused. So here, x to the sixth to the power of 2, right? X to the sixth squared. So I'm just going to go ahead and multiply this squared. I'm going to distribute this 2 here to the sixth. So x, right, this is just again, and last time I'm going to do it, x times 6 times 2, x to the 12. Well, we're going to take that exponent, multiply, we're going to distribute it into that other exponent. So 12 times 2, m to the 24th. Now here I've got two variables. Well, now we're going to go ahead and distribute it twice. We're going to distribute it to the sixth and to the third. So x to the power of 6 times 2 is 12. Y to the 3 times 2, so that's 6. And even though here, right, notice that I have this 5 here, um, it still does have an exponent, the exponent being 1, right? I have 1, 5 there, so it's just 5 to the power of 1, right? 5 by itself, one time. Um, so what we can still do is we can still just go ahead and distribute that. But remember, 5 to the power of 1 times 2, well, that's 5 squared. I'm actually going to place this down here. 5 squared. And then 4 times 2 is 8. So x to the 8th. Now, 5 squared I know is 25, so my final answer is going to be 25 times x to the 8th. Perfect. All right. Now, I suggest you guys trying this and then coming back to the video. So please do that. But I'm going to go ahead and start solving these 6 here. So again, I'm just going to go ahead and just multiply my exponents because it's an exponent to an exponent. So a to the 4 times 3 is 12. X to the 8 times 2 is 16. I'm going to distribute this exponent at the outside with all of the ones on the inside, right? We're just essentially distributing, right? So x to the 4 times 2, so that's 8. Y to the power of 2 times 2, that's 4. 2 to the power of 5 times 3, that's 2 to the 15. Now you could leave it like that. I'm going to go ahead and just multiply it, but you can just leave it like this, honestly. Um, I wouldn't mind, unless the instructions specifically say, oh, wrong. That's not what I meant to do. Sorry, you did not see that. We had 32,760. And that's it. Perfect. Mastered it. All right. Anything that doesn't have an exponent, I just like to go ahead and add an exponent. Oh, well, there's purple here. All right, so I'm going to go ahead and add an exponent to the 4, an exponent to the 6, an exponent to the 2, exponent to the x. Cool. Everything has an exponent, so let's go ahead and start this. Distribute this in. So I get 4 to the power of 3, right? 1 times 3. 2 times 3 is 6. Then I have y. 6 times 3 is 18. Now 4 to the third power, well, or 4 cubed, that's just 64. And then we have x 6, y 18, and we're done. Now here, it's not as easy as all the above, right? All of the above were already fully simplified, and we just added an exponent. Number 6, this is not fully simplified, and we have exponents. So in this case, what I'm going to do is I'm going to go ahead and apply, right? We have to pull 2x out of the parentheses, out of its box before we can play with it. So I'm going to go ahead and distribute this 2 into the 2 and the x here. So I still do have my 6 to the 1, x to the cubed, right? X cubed times 2 to the power of 2, and x is 1 times 2 is to the power of 2. And now I can almost start doing combining stuff, right? In this case, I know for a fact I can combine these x2s, right? X to the power of 3 times x to the power of 2. Well, remember when we multiply bases like this, we keep the base, exponents add, so I have 5, 3 plus 2. And now 6 to the 1 times 2 to the time 2 squared times x to the 5 is almost where I'm done. Well, 6 to the power of 1 is 6, 2 to the power of 2 is 4. So now I can go ahead and just finish this, right? These guys here, these coefficients here, I guess they were coefficients. We can just multiply them. 6 times 4 is 24. And then we have x to the power of 5, and we are done. And that's it. That's my final answer. All right, perfect. Let's keep going. Now, what happens when we have a fraction to a power? So it's essentially the exact same thing as before. We take that fraction, or we take that power, and we distribute it into the exponents of every other part of this fraction, whether it be above or below, in the numerator or the denominator. So 2 to the power of 1 times 4 is 2 to the fourth. 3 to the power of 1 times 4 is 3 to the fourth. So let's go ahead and see what that looks like. Again, why does that work that way? Well, if we had x over y cubed, well, that's just x over y times x over y times x over y. And remember, when we multiply fractions, it's not too bad because we just multiply across. X times x times x, well, that's just x times x to the 1 plus 1, which is x to the 3. And same thing happens below, right? When we do y times y, well, that's just y to the power 3, or y cubed. And we're done. So essentially what we did is we took this 1 and this 1, and we distributed it. So actually, I'm going to go ahead and move this over to my answer. Cool. Cool. So let's go ahead and do that. So this is just going to be x squared over y to the 5th times x squared over y to the 5th, which is honestly, again, remember, it just equals x to the power of 2 times 2, y to the power of 5 times 2. So x to the 4th over y to the 10th. And we're done. Oh, and if we really wanted to, might as well do it above, right? X to the 1 times 3 and y to the 1 times 3. Perfect. All right, let's move on. Now I'm here. Again, I'm just going to go ahead and add exponents to anything that doesn't have an exponent. Perfect. And now I can go ahead and start distributing. X to the power of 2 times 3, well, that's just x to the power of 6. Y to the power of 1 times 3 is y to the 3rd. Done. X to the power of 5 times 6, well, that's just x to the power of 30. Y to the power of 3 times 6, that's y to the 18th. 2 to the power of 1 times 2 is 2 squared, and I'm actually going to write that here. So I'm just going to fully simplify it since I'm already there. X to the power of 3 times 2 is x to the 6th. 2 to the power 3 to the power of 1 times 2 is 3 squared. And then y to the power of 1 times 2 is y squared. Now I know that 2 squared is just 4. X to the power of 6 stays as x to the power of 6. And then 3 squared is 9. And then y to the power of 2 is just y to the power of 2. So that's actually my final answer. I cannot simplify 4 over 9. So we just leave it as is. Done. Change color. Let's go with yellow. Why not? So again, you try. I suggest you guys taking a few minutes, trying this go as far as you can. And then from there, come back and get the answers from here. All right. But I'm going to get started. Again, everything has an exponent, so I'm just going to go ahead and just start distributing my exponent here into my exponents of my variables in my fraction. So 8 to the power of 2 times 4 is 8 to the 8th, a to the 8th. And then b to the power of 3 times 4 is b to the 12th. Done. I'm going to put 1 here so that I have an exponent to multiply with. M to the power of 1 times 10 is m to the 10th. And then p to the power of 2 times 10 is p to the 20. Done. Here we go. Now there's a lot of missing ones, right? So I've got a 1 here, and I've got a 1 here, and I've got a 1 here, and I think that's it. So now let's go ahead and distribute everything. X to the power of 1 times 4 is x to the 4th, and actually, oops, ignore this extra equals sign. Y to the power of 2 times 4 is y to the 8th. And last but not least, z to the power of 1 times 4 is z to the 4th. Done. And that's a 4. I'm not really liking how that's looking, so let's change back to green. 2 to the power of 1 times 3, well, that's 2 to the 3rd. 3 to the power, or x to the power of 3 times 3, well, that's x to the 9th. And then y to the power of 2 times 3 is y to the 6th. Now, 2 times 2 times 2, well, that's just 8. And so I'm going to write 8 here. Come on. And then because I can't simplify the x's or the y's, we're actually just done there. And we're done. So far, it's not been too bad. Where it starts to pick up a little bit is right here. Because here we're going to start to have to make some choices. We can either start simplifying first, and then distributing, or we can distribute and simplify at the end. Both options are fine, but I usually like to simplify first and then distribute. But in this case, we're going to have to simplify once and distribute once. So I'm just going to show you what it looks like when we simplify at the end and when we versus when we simplify in the front and number six, in the beginning and number six. So here, I'm going to go ahead and just put a 1 over anything that doesn't have an exponent, and then just start by distributing the exponents. So I have 4 to the power 1 times 3, so that's 4 to the third. X to the power 2 times 3 is, excuse me, x to the sixth. Y to the power of 6 times 3 is y to the 18th. And then 2 to the power of 1 times 3 is 2 to the third. Now from here, we can apply. I'm going to do 4 to the third, right? I'm going to evaluate what that is, and then I'm going to simplify at the end. So 4 to the third is 64. X sixth, y 18 over 2 to the power of 3, which is 8. And now 64 divided by 8 is going to be 8. So when I divide 64 divided by 8, right, I get 8 over 1. So I'm just going to write that 8 divided by 1, and I'm going to have x to the sixth, y to the 18th. Now, this answer is perfectly sufficient. But remember, whenever we divide anything by 1, our answer is just the top. So my final answer here is going to be 8x to the power of 6, y to the 18th. Here we go. We're almost done. Now here, I'm going to go ahead and, and simplify first and then distribute, and show you the difference in work that we have to do. And then from there, you guys can end up picking whichever one you like. I prefer to usually, I mean, it's always different, right? But I like to usually simplify first and then distribute. But here, let's go ahead. I'm going to put a 1 over anything that has an exponent. 2 to the 1 times 2 is 2. Or, yeah, and then x, the 4 times 2 is x to the 8th. This is y to the 14th. That's x squared. And remember, that's all division. And then that's y sixth. Perfect. Now let's go ahead and simplify. Well, I know that 2 squared is 4. I'm done with this. I also know that the highest variable, or the highest exponent on my x, is the 8th there. So I'm going to have x is above. And when I cancel 2 here with 2 on top, well, I'm left with 6. And y's are up top as well. So I know y is going to have to go on top, which means everything here is going to be under 1, right? Remember, that's because whenever we have x over x, that equals 1. So we can put a 1 under there, but you don't need it. But remember, you always do need a 1 on top if you have nothing left. So in this case, we have nothing left in the bottom, so I'm going to put a 1. And when I cancel 6 here with 6 on top, I have 8. And again, same thing as before. Whenever we divide under 1, our answer is just the top. So my final answer here is 4 x times x to the sixth, y to the 8th. And we're done. Cool. So that's essentially it for notes. We have 3 more problems here, which I would love for you guys to do alone and ask Miss Tergier and Mrs. Sosa for help if you guys need to. I am going to do them here. So if you want to follow along, feel free. Otherwise, if you want to do them on your own, you can always come back here or ask one of the teachers in class to see if you did this right. So I'm going to get started and then we are done, and you guys can get started on the homework, which is the following worksheet on your packet. So let's get this started. Remember, anything that doesn't have an exponent, I can apply 1, but my favorite way of doing things is to simplify first. So I'm going to go ahead and start by simplifying anything that I can. So let's go ahead and do so. All right. I know that I can't divide the 3, so I'm going to keep a 3 on top of my fraction. And I know that x has the higher exponent on the top, so we're going to have an x on top. When I cancel 1 on the bottom here with 1 on top, well, we're going to have 1x left. So we are done with the x's. Same thing with the y's, right? Oh, I guess not same thing with the y's, but with the y's, we have a y with the bigger exponent on the bottom. So I'm going to have a y down here. And now I'm going to cancel 2 up top with 2 on the bottom. So that's 4 minus 2. So we're going to have left with 2 y's on the bottom. Now, all of this is in parentheses, the power of 3. And now I'm going to go ahead and distribute everything out. 3 to the power of 1 times 3 is 3 cubed. X to the power of 1 times 3 is x cubed. Y to the power of 2 times 3 is y to the power of 6. Now we could stop here, but I know that 3 times 3 is 9, times 3 is 27, so I'm going to go ahead and put 27x cubed divided by y sixth, and that's going to be my final answer. Number 2. Here I can't simplify first because everything's being multiplied, right? And remember, before we can start playing with things inside of the parentheses, we have to take it out. We have to take our present out of the box before we can play with it. So let's go ahead and see if we can take this out of the parentheses. And the only way of doing so is by applying the exponent on everything. So let's go ahead and do that. So 4 to the power of 1 times 3 is 4 to the third. M to the power of 2 times 3 is m to the sixth. And that's multiplied by 2 to the power of, and that has a 1. So 1 times 2 is 3 to the second. And m to the power of 4 times 2 is m to the eighth. And now let's start. I'm going to start by combining these m's because it's easier, right? So m to the power of 6 times m to the power of 8. Remember, your base stays the same. Your exponents end up adding. So we have m to the 14th. And now this is just going to be 4 to the power of 3. Well, 4 to the power of 3, that's 16 times 4, which is 64. And times 3 to the power of 2 is 9. So that's where I got this is 3 squared, and I just evaluated the 4 cubed and the 3 squared. Cool. And now to finish this up, I'm just going to do 64 times 9. And 64 times 9 is 576 m to the 14th. And that is my final answer. Last but not least, this problem here. All right, remember, we have to pull things out of this parentheses before we can start doing stuff with them. And the only way of doing so is just to apply our exponent. So I'm going to put 1 on everything that's missing an exponent, and now I'm going to go ahead and apply it. So x to the 3 times 2, well, that's x to the 6th. And y to the 4 times 2, that's y to the 8th. And that's all being multiplied by 1 to the power of 1 times 4, which is 1 to the 4th. And then that's being divided by x to the power of 1 times 4, which is x to the 4, and y to the power of 3 times 4, which is y to the 12th. But what happens here? Like, how can I combine these? Well, remember back in the day when we did slope, right? If you had a slope of 3, well, that was just 3 over 1. We can divide things by 1 without changing the value, right? It can still look like a fraction, but the value stays the same. So that's exactly what we're going to do here. And the reason we're doing that is because we're just going to multiply across. So if I multiply across, I'm going to go ahead and evaluate this number here first, since it's a whole number to the power of 4. Well, that seems like it's going to be pretty hard, right? 1 times 1 is 1, times 1 is 1, times 1 is 1. So 1 to the power of 4 is 1. And now multiply that by x to the 6th times y to the 8th, and we're done. Same thing in the bottom here. 1 times x to the 4th, well, that's just x to the 4th, times y12, it's just with y12. Right? We can't really, we already multiply the 1, so we don't have to distribute it because they're not being added. So there's no distribution here. And now I have this 1 in front. Now you could leave it like this and this would be correct. However, remember when we have a 1 and it's not doing anything, we just don't apply it. So I'm just gonna say this makes sense. They cancel each other out. I mean, kind of, sure, they become 1. But remember, whenever we have a 1, we don't apply it, or we don't put it, you know, we don't show it. So here we have x to the power of 6. Actually, and let's just finish simplifying this. I'll do pink. Let's go back. Black. And now we can simplify my x's. So x on top is bigger than the bottom, so it's going to go on top. I'm going to cancel 4 here with 4 up top, so that's going to leave me with 2. Y at the bottom is bigger than Y on the top, so I'm going to go ahead and cancel the one on top. Minus 8 down here gives me 4. And that is my final answer. Again, if you guys have any questions, please feel free to reach out to me by email or talk to, and obviously I'll get to back to you guys whenever I can. However, you do have great teachers in class that can help you. I will see you guys on hopefully Friday, but if not Monday, have a great day. Finish up your homework. It's the next worksheet on the packet. Bye, guys.